Graphing piecewise functions. So basically when we're looking at piecewise functions, we're given more than one function that we're going to put on the same graph. It's sort of like an if-then statement in a way. So sometimes for our function here, sometimes the function we're going to be using is the constant function 2, and that's only when the x values are greater than 3. And then other times we're going to use the function x plus 1, and that's for any x values that are less than or equal to 3. So if we look at our graph, x equals 3, 1, 2, 3 would be right about here. So this line represents when x is equal to 3. So basically, when we're looking at x greater than 3, then that function we're going to put on the right side. And then the other function, the x plus 1, since it's when x is less than or equal to 3, is going to go on the left side of that line, x is equal to 3. So we're putting two different graphs on the same xy plane. Let me get rid of this for now. And let's start by looking at the first one. So f of x, the first function, is essentially just equal to 2. And so that's for any x value that's greater than 3. For example, if we had f of 4, well, since it's just a constant function means the output's always 2. If we had something like f of 5, the output would still be 2, and then so on. If I went to actually graph the function f of x is equal to 2, it's the same thing as saying y is equal to 2. So we get a horizontal line at 2. So if we were just asked to graph the function f of x is equal to 2, then we'd be done at that point. But since it's a piecewise, we go back and say, well, this is only the graph for x values greater than 3. So essentially, whenever it's less than 3, I'm actually just going to remove that portion of the graph. And then right at 3, I would say, well, is it included or not? So x greater than 3 means 3 itself is not included, only numbers greater than 3. So at that point, I'm going to put an open circle. So that's one piece of our graph. So if I label it, this is our piece. That's f of x is equal to 2. You don't have to label it, but essentially that's our graph. So then we move on to the other one. So if we have x plus 1, basically our function is equal to x plus 1, but only for values that are 3 or less than 3. So if I wanted to figure out something like f of 3, since that's in that interval of being less than or equal to 3, that's the function x plus 1 is the one I would use. So for example, f of 3 would be 3 plus 1, which is 4. If I wanted to find something, I'm just going to keep using integers, f of 2, that would be 2 plus 1, which is equal to 3. If I keep moving, I'm just going to skip one. Let's say if we did f of 0, we would have 0 plus 1, which is equal to 1. So all I'm showing is if we're just plugging values into the function, which we could just like any function, we would plug it into the top one as long as the value is greater than 3, and we'd plug it into the bottom as long as the value is less than or equal to 3. In terms of graphing it, well, we could graph this second function by plotting points like we've sort of done just below then. You could also use the fact that it is a linear equation, so like the mx plus b, so in this case our function is actually 1x plus 1, so it happens to have a slope of 1 and a y-intercept of 1, which essentially means b being 1 means my y-intercept right here, I would plot that on 1. A slope of 1, the top number indicates how much you move up or down, so we move up 1, the bottom number is left or right, it's positive, so we move to the right 1, and then I could just keep plotting points that way. Of course, if I look at the points I've already plotted, well, f of 3 is 4, so I've also got the point 3, 4, which is right up here, 2 and 3, so right here. So either way I graph it, what you see is that all of these points are all in a straight line, and so it's all points on the same linear function. So if I was just going to graph f of x is equal to x plus 1, I would just connect all of these points and be done. Of course, the extra thing is here is that it's only for the x values that are less than or equal to 3, so I'm going to erase the other part. So over here on the right, that's not the function when it's greater than 3. We had a different function. So I'm going to erase all the way to 3. So one difference you'll see is that on 3 here, for this function, I'm going to keep it as a closed circle, and that's because the 3 was actually included for that part. So here, on the left side is our one function, and on the right side is the other. And this is pretty much going to be the case for all piecewise functions. You're basically graphing however many functions are listed, but only for the given x values. So in this case, our x values were split up at 3, greater than 3, and then less than or equal to 3.